Hello everyone, my name is Juan and welcome to this week's video. Today I want to talk to you guys about asymptotes. So let's get started. First of all, we have to talk about what an asymptote is. An asymptote is a line that approaches a curve but never gets to meet it. So the curve and the asymptote will try to get closer and closer and closer together, but they'll never touch each other. Never. Now where can we find asymptotes? We can find asymptotes in a huge variety of curves, including the trigonometric functions. But there's a family of curves where you can find a lot of asymptotes, and they're called rational functions. And today we're going to focus in those functions. We can classify asymptotes in three different groups: vertical asymptotes, horizontal asymptotes, and oblique asymptotes. Let's talk about the vertical asymptotes first. We can see this type of asymptotes when a function starts growing at a specific point. And we can find them using math when a limit at a specific point coming from the left or from the right is infinity. There's a great example of vertical asymptotes in rational functions. In rational functions, there's a vertical asymptote at a point x such that the denominator is equal to 0. Why is that so? That's because we simply can't divide by 0. For instance, the function 1 over x minus 1 is going to have a vertical asymptote when x makes the denominator equal to 0. So we have to make our denominator equal to 0. So x minus 1 equal to 0. And therefore x is equal to 1. So the vertical asymptote is going to be at x equals 1. Second, we're going to talk about horizontal asymptotes. We're going to have a horizontal asymptote if the limit as a function approaches infinity is a specific value. That is to say that, for example, we have a function that as it approaches infinity, it will tend to be 3, for example. So it will tend to be 3, but it will never be 3. Now I'm going to show you how to find horizontal asymptotes in rational functions using math. So I already told you that we're going to calculate the limit as the function approaches infinity. So we're going to do that in any rational function. If we're going to do that, there's a good rule of thumb that says that if you're calculating the limit as any rational function approaches infinity, then the only coefficients that are going to matter are the leading coefficients, which are the terms that have the highest power in the numerator and the denominator. Let's see how it works in an example. We have the function that is right here, and we have to see whether or not it has a horizontal asymptote. So we have to calculate the limit as the function approaches infinity, right? So the only terms that are going to matter are the leading terms. So 3x cubed over 2x cubed. And we're going to calculate the limit of that term. So we're going to calculate the limit as x approaches infinity of 3x cubed over 2x cubed. The x's are going to cancel each other out, and we're going to calculate the limit as x approaches infinity of 3 over 2. Since there's no x, then the limit is going to be just 3 over 2. Therefore, there is a horizontal asymptote because the limit approached to a certain value. If it approached to like infinity, there wouldn't be any horizontal asymptote. Finally, we're going to talk about the oblique asymptotes, but we can call them slant asymptotes as well. We find these asymptotes when the degree of the numerator is 1 greater than the degree of the denominator. For instance, we have this function. As you can see, the degree of the numerator is greater than the degree of the denominator just by 1. We're going to do the long division of the function, and we're going to end up with something like this. Finally, the linear function that we end up with, which is the part that is not a fraction, is going to be the oblique asymptote of the rational function. So that was it for this video. I really hope you guys enjoyed it, and if you did, please don't forget to give it a big thumbs up and subscribe if you haven't yet. If there's a topic that you want me to go over in my next video, please put it in the comments down below. Please don't forget to share this with all your friends, and I'll see you all in my next week's video. Bye.